Hey everybody, this is Larry. This is me doing a bonus extra question, trying to get myself, try to get myself to do a problem that I haven't done before. That's basically and get my money's worth on RNG. Give me a good one, Larry. A Leetcode AI. Why am I talking to myself? It's kind of weird. All right, today's problem is, and it's not a premium problem, but it is a problem with a lot of downloads. A 22 card flipping game. So you're given two zero index integer arrays, front and back of length, and where the ith card has the positive and then back on the other side. Each card is placed on a table. The front side is on the front. Okay, then you may flip over any number of cards. After flipping the cards, an integer is considered good if it's facing down on some card and not facing up on any card. Return the minimum possible good integer after flipping the cards. If there are no good integers, return 0. Alright, what does this mean? I think the critical part is just like this, right? An integer is considered good if it is face down on some card. So basically, if it's on the back, if you will, and not faced up on any card. Alright, and we can flip any number of times. Okay. So, well, this one's a little bit awkward immediately. Because the first thing I wanted to check is n, and if n is equal to 1000, I think that's it. That's like GG, right? What I mean by that is that because then now you can do an n square thing. The only n distinct numbers, I guess n times 2 distinct numbers, you could just check all of them in a greedy kind of way, and that'll be n square. Like you can, for each number, you can see if it can be good, and it is good if if you could flip everything here to, like, if that number is not on the front side after flipping, right? So I think that's basically how I would attack this. I'm a little bit confused about the downloads because is it an interesting problem? Not really, but is it I don't know. I don't see any like weird like edges for this one, edge cases. The only one that I had considered was actually this one, but they have it in an example, so I don't even think that's okay. So yes, I don't know. So the right, so maybe let's just say this is the set of numbers, right? So then now we sort them. Yeah, so now for x in sorted S, right? So then now we just try to see if x is good, and we return 0 if there are no good integers. So yeah, so this is good if alright, let's just say if good x, then we return x. I'm a little bit lazy, right? I'm a little bit, we can abstract it. So then x, so the number is good if it is face down on some card and not face up on it. So then for now, for front back in zip of fronts backs, maybe we'll discover a weird edge case and then we'll see. But basically we have to be okay. So found maybe is going to force, and this is just to show that it is face down somewhere, right? So yeah. So if but like you can flip every card, so it doesn't even make sense, right? So the only time where you cannot do this number is if, I don't know. I'm gonna go with the n square one, but yeah, if front is equal to x or back is equal to x, then found is equal to true, right? If f is equal to x or f is equal to b, n is equal to x, then we return false because you cannot flip both sides, and that's really it, right? Like, we just have to, and because we always choose a number that's in here, so this is always going to be true. I don't think that this can be false because we always choose a number that's in here. So I'm like assert found, right? Because I'm just like really confused about this problem. Or I'm really confused about like how, you know. Okay, I mean, I don't know why there's so many downvotes. I guess that's the thing. And now that we kind of confirm it, I mean, it doesn't change the complexity. That's why I left it in. Otherwise, you know, you can even just done something like this and then just return true, right? So then now this is, you know, slightly cleaner. And then now can we even optimize it a little bit more? You know, we just changed like a lot of operations, but yeah, I mean, we can probably do it the other way, right? Now that we know that this I mean, to be honest, I didn't really have motivation to prematurely optimize it because n is 1,000, right? Like we said, solve the problem that you're given. If n is 1,000, I'm not going to prematurely optimize, and this is n squared. You know, this is n. Yeah, I mean, this is still n, even though we have sorted, so it's n log n from the sorting. But you know, it is an n squared solution, so it's going to be dominated by the n squared and not the n log n. So that's why it's n squared. But now that we kind of see this property, we can just kind of keep track of where all the things where this is the case, right? So then now we can we don't even need to sort it, right? So then now maybe we can just do like for fun back in zip of fun's backs, right? So then now we could do maybe like doubles as a set, and then seen as a set, I guess. I don't know, something like that, right? And then now we add fun, we add back, and then if f is equal to b, then doubles dot add f, right? Then now we can just return the min. Well, I guess I think we could do that. You could do seen minus doubles with the default of 0, something like that, right? I think default is the thing, right? I didn't make this up. Yeah, so then now this is linear time, linear space, and yeah, pretty straightforward. I was thinking about this during the problem solve, but I just, you know, didn't want to, like if this was a contest, I would definitely not have done it this way for sure. I would have done the n square way because I don't have to prove anything. Or I guess maybe there's a little bit of proof, but it's not as it's not that difficult of a proof. Where here, you know, you have to really you have to be really confident about the proof, right? So this one's really awkward, mostly due to you can flip any number of cards. I think if you have limited number of flips, I guess that changes the problem a bit. But yeah, I don't know why I would download though. I am curious. I'm gonna just check out the solution. I wish there's like a forum or something. Is there a forum or something? I don't know. I'm just really curious why I don't know. I mean, I guess it's not that important, but I think I was just very curious why there's so many downloads. I mean, is it like I said, is it an interesting problem? Not really. But is it a bad problem? I don't know. It's a little bit tricksy, but I don't know if it's a bad problem per se. But yeah. Alright, friends, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.